we go. Remember, organic acids end in COOH. So our acetic acid then will be CH3. And if we put it together with the H plus, those are each 1 and 1 CH3COOH. Charges balance out. When we add up the molar mass for this, we have 2 carbons, 4 hydrogens, and 2 oxygens. So that's going to be 2 times 12.0, 4 times 1.0, and 2 times 16.0. So that's 24, 4, and 32. Technically, when we are adding up the masses to make the molar mass, this is an addition problem. Even though we can do some of it by multiplication, we're technically adding 2 carbons and adding a hydrogen and a hydrogen and a hydrogen and a hydrogen. We could add them up all individually. What is the sig fig rule for addition and subtraction? And I'm not sure this is your question, but I wanted to talk about it today anyway. So what is the sig fig rule for addition and subtraction? Yes? We have to take it to the first uncertain digit, which is usually, if there are decimal places, it's going to be the largest of the decimal places, okay? So this is going to go to the first uncertain digit, or the smallest number of decimal places. So if these are our numbers here, then our uncertain digits are all the zeros. Yeah. So when we add that up, we get 60.0. And because this ending 0 came from all these uncertain digits here, that is our single uncertain digit. So our final answer would have 3 sig figs, with that last one being the uncertain digit. Did that answer your question? Okay, I thought probably, yeah. So yeah, when you are doing molar masses, when you are calculating molar masses, assume that you are adding and subtracting. And because your periodic table always has 1 decimal place, your molar masses will always have 1 decimal place. If you have, like, let's say 2 years from now, you are now writing the AP exam, you would have 2 times 12.00, I think that's what they give you on there. You would have 4 times 1.008, and you would have 2 times 16.00, and you would say, okay, I've got 24, I have, what's 4 times 8 is 32, 4.0, hang on, 032, 032, and then we would have 16. So it would be almost the same, except for we would have this little 32 at the end, but we would still have to round, we would still have to say we only have, our first uncertain digit is in the hundredths position. $60.032, and this would have 4 sig figs. Did I do that right? Huh? Oh, 32. Yeah. Yeah, 2 times 16 is 32, not 16. Yes. So technically what I would do is if I were doing the calculation, I would use that number, but I would know that it has 4 sig figs, and I would say, if that's my smallest number of sig figs in any further calculations, I can't have 5 sig figs because that doesn't actually have 5 sig figs. Yes? Yeah. Yes. And that's when you're adding, but let's say you then took this number and did a calculation with it, okay? So let's say that you had 4.3257 grams of acetic acid, CH3COOH. Okay, so that has 1, 2, 3, 4, 5 sig figs, yes? Okay. And let's say you wanted to know how many moles that was. I would use the entire number here, okay, but I would probably underline my uncertain digit for myself so I kept track of it, okay, and then I would have 1 mole up here. Now, when I do the division, I get some random number that I don't know. Quickly plug this in. 4.3257 divided by 60.032 equals, and I get 0.072056569. Okay, that's what my calculator spits out. All right. Now, this number here has 5 sig figs, but because my first uncertain decimal place is in the hundreds position, that means that this number here has only 4 sig figs. So even though I'm going to keep that 2 in there to prevent rounding errors, probably I won't get one because 2 is a small number, but if I had something like a 4 or a 6 there that's close to 5, those are the kind of numbers that tend to create rounding errors. Use the unrounded value, but then say, I know I can only go to 4 sig figs here, so this would then become 0.07206 or 7.206 times 10 to the negative 2. Yeah? And if you're like, oh crap, that was awful, don't worry. Most of the time we're only adding and subtracting or multiplying and dividing. It's a little more complicated when you do both. But in the AP exam, they're not trying to trick you with sig figs, right? Like if you want some tricky sig fig stuff, I can get you like I have this thing called the Big Sig Fig Review, and it kind of, puts you through your paces. It has horribly difficult questions that you will never end up dealing with in real life. Okay, so let me know if you want one of those and I can get you one of those, and it does put you through your sig fig paces, okay? Any other questions? Yes, Devashri. Oh, either way, whoever wants to go first. Yeah, Devashri. Yeah. She's nice. Okay. It should definitely be 10 to the 27. Yes. Okay. So on page 9, it should. This is 5.1c, number 1b. The power of 10 should be 27, not, or negative 27 or whatever it is, not 21. Yeah, for sure. Oh, and this is probably another one. Is it 2D? 3C. Okay, so let's take a look at 3C. And your question is, okay, you just keep getting the wrong answer. Let's try it out and see how it goes, okay? Oh, and I wanted to also talk to you guys. Don't forget to get me to teach you about the magic button on your calculator today. Okay, because most of you don't know that it exists at this point, and it will save your life. Maybe that's even the problem that you're having in this question. We'll see. Okay. If you're getting the right number but the wrong power of 10, this is a calculator problem. Okay, so if you're getting the right number but you're getting a wrong power of 10, it's a calculator problem. So what you would want to type on your calculator for this business here, where it says times, you do not want to do this. This is no. Times 10 to the 25. Okay, for this part here, that's a no. Don't do that. You're like, well, what do I do then? Or sorry, there should be a little caret in there or something. You know, one of these things. Something like that. Okay, don't use that. Don't use the caret. No carets. Okay, no carets. No, we don't want this one either. I don't care. Okay, so those buttons, don't touch those buttons. I will show you the buttons that you want to use. The buttons which, this is no here, no. The yes button has 3 different forms depending on your calculator. You might see a button that says that. You might see a button that says EE, or you might see a button that says times 10 to the x. That is different than the 10 to the x button. There may also be on your calculator somewhere a 10 to the x button. This is again a no. Okay, if it is on your calculator like this, it will literally say times 10 to the x. That button is all those keystrokes in one. So what you would be typing, let's say for 1 mole, what you would be typing is you would be typing 6.02, and then you're going to type either whatever your calculator has, EXP or EE, or the times 10 to the, and then 23. You can do it without this button, but then you're using a lot of brackets. Okay. Because for this question, you would actually have the numbers, if you use the times 10 and punched in all of those things, if you type in 8.25 and you type in times 10 to the 25, and then you'll say divided by, right? You want to divide by both the 6.02 and you are also dividing by the 10 to the 23. Yes? Both of those are in the denominator. Yes? If you type 6.02, what that means is you now have 8.25 times 10 to the 25 divided by 6.02. If you now type times, your calculator says times, put it in the numerator, and if you now type 10 to the 23, what you will end up with is times 10 to the 23 with your 23 power of 10 in the numerator, because that's how your calculator thinks. Yes? You could put all of this in brackets, but that's like 8 keystrokes more than just using the exponent button, like the EXP button. When you use that, it says this is all one number. So if I was to type 5 EXP 8, that means all of this together is just one number. Your calculator treats it as one number. There's no need for brackets. Okay? Is anyone unable to find that button on their calculator? Let's take a look. All right, one more calculator thing that you need to know about, okay? And that is, there are 2 different buttons with a negative sign. Okay, what did I do with my pen? There it is. There is this button, which means minus. Okay, we all know that one. We've been using that one since grade school, right? There is also one that will either look like this, or it will look like this. And that means negative. So if you want to type times 10 to the negative something, use this one. If you want to subtract, use that one. So this one is for subtraction. This is for making a number negative. Every once in a while, it'll do the right thing for you regardless. So it's a little confusing, but if you want to always be correct, that's the way to use it. And if you cannot find that button on your calculator, let me know. Okie dokie. All right. Shall we look at a mole ratio today? Page 24. Unless anybody had any other questions. Yes? No, it's fine. Yep. Unless we're doing a lab, but that's kind of obvious. 5.1i, page 24. There's actually not much to this. It's pretty straightforward. Page 24. A mole ratio is just a particle ratio's big brother. So if you are okay with taking a look at nitrogen dioxide, or sorry, dinitrogen, why does it say nitrogen dioxide? That's not even correct. It should say dinitrogen, what? Tetroxide. So this is wrong. Dinitrogen tetroxide. Okay. So if you have one dinitrogen tetroxide, it should be pretty obvious that you have two N atoms, and you can write that as a conversion factor, of course. You've got two N atoms per one N2O4 molecule. We're all good with that? Excellent. Let's scale it up a little bit. Now I have one, instead of having one molecule, I have one pair of molecules. Yes? Which means that I have two pairs, yes, of N atoms. But do you see how the ratio is still the same? It is still a 2-to-1 ratio. I have one pair on one molecule and one pair on the other molecule. So that's nice. Now if I scale it up to a dozen, right, I can look here and say I have 1 dozen N2O4 molecules, and then I have, how many N atoms do I have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. That's 1 dozen. And then I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 2 dozen. Yes? So I still have a 2-to-1 ratio. This time I have 2 dozen N atoms for 1 dozen N2O4 molecules. So that 2-to-1 ratio just scales up when we go to a pair or when we go to a dozen. If I had a gross of N2O4 molecules, that's 144, okay? I would have 2 gross of N atoms. And so if I scale up to a mole, which I did not draw, you can say thank you, okay? Your book would be like this big, okay? No, it probably wouldn't even fit in this room. Okay, if you have 1 mole of N2O4 molecules, you have 2 moles of N atoms, and you can write that as a conversion factor. And that's all that a mole ratio within a compound is just taking that particle ratio and putting the word mole in there, okay? So nothing that you don't already know. Okay, we could also write it between N atoms and O atoms. If you have 1 N, if you have 2 N atoms, you have 1, 2, 3, 4 O atoms. So that's a 2-to-4 ratio. If you have 2 pairs of N atoms, there's 1 pair and a second pair, you will have 1, 2, 3, 4 pairs of oxygen atoms. So again, it's that 2-to-4 ratio, okay? We could do it with a dozen, and we could do it with a mole. So it's still a 2-to-4 ratio no matter what you've got. Yes? Yep. Why are we putting it to moles? Because sometimes it's going to make our life so we don't have to do 3 calculations, we only have to do 1. Okay, yeah. Because sometimes you want to go directly from moles of one thing to moles of another. You could convert it to particles and then use the particle ratio to go to the other particle and then go back into moles, but that's a pain in the butt. Yeah? Okay, so here we have dicarbon hexachloride. sorry. So we have 2 moles of carbon and 6 moles of chloride. So here's our mole ratio, 2 moles of carbon to every, what? Oh yeah, I don't know what I'm doing here. That's just an example. Let's keep moving. There's some exercises here. Do you guys think you could do the exercises based upon this? Okay, excellent. Go for it. Do it. There we go. There's also a little bit of ionic covalent acid here for you to take a look at. By the way, if anyone needs volunteer hours, let me know because I have this same workbook printed out for my regular grade 11s when they get to it and all these corrections. It would be nice if they were done beforehand. So let me know. You can drop by like during flex or after school and I can like let you know where things are and we'll just start going through. And if not, it's me doing it by hand. So yeah. But yeah. Yes. Yes. I have. And in fact, some of them still need it for the next. Look what I have though. It goes. It's actually like way more fun than I thought it would be. I was not looking forward to doing that. And I was like, ooh, but I have the rules. If you finish this, you could do 1.1H. Okay, if you finish this, try pages 20, 21, 22, 23. Maybe just the odd numbers, because otherwise it gets boring. Okay, let me get rid of this. I'll write it up here. Hang on. Yeah, that's the one you're doing right now. (5.1H) has two-step conversions. If you're having any difficulties with it, stop me and I will give a mini lesson on it. Okay. What? Exo 6? Hexo 6? Hexon. Hexon. Yeah. Hexon is 6. You're doing great? Okay. I feel like I got next to you, so I'm very fine. Your posture felt right in the way. Somehow. It was better when I was younger because I used to sit behind all the Oh, you're not doing my class. Yeah, that's much better. I just think that like we could have been a room on. I don't know. And the only reason for that is that Oh, no, no, that was my grade 9, but I'm too short to erase it. There, yeah. What's that? I have a step stool. Yeah. But when I'm erasing, I don't usually haul it out. I usually just jump, but I've given up on any sort of resemblance of like looking like a normal person, and I've gone full fanny pack. The water is because I go walking and then I forget to take it off, so I walk during my spare because I'm over the age of 50 now, and if I don't exercise every day, my health is going to do this. which it started to do over the last 2 years because COVID. All these workbooks were due to COVID, and all I did was sit on my butt every day and work on these. And yeah, no, I was in terrible, terrible shape. Like my hips were yeah, just problems, problems. So yeah. What's that? Yeah, I've given up on anything resembling fashion, and I'm just like, you know what? I like having my phone with me at all times. I like having my shoes with me at all times. And the first odd numbers only. So if you've already done it. Oh, no.
Which is weird. No, but then we do this actually. Three negative. But it's still like they could have done it the other way. Yeah. So now they
If any of you ever forget your calculator, I'm so happy you're using your calculators and not your phones, because people who use their phones are generally crippled by um, the lousy calculator on the phone. But if you ever do want a calculator app, Calctastic is free and it looks like a good scientific calculator. I've used it on my phone and it gives you good results. So that would be the one that I would recommend for a calculator. sometimes the covalent compounds that I deal with are like made up, just to make you know all your prefixes. Yeah. Because there's really, I mean, otherwise we're doing di and phi all the time. And it's just, would you guys be ready to do a quiz on 5.1 and 5.2 on Thursday? Quiz 5.1, 5.2 on Thursday. That gives you lots of practice time between now and Thursday. We've basically covered almost everything that's in there. Now it's just time for a little bit of practice and stuff. Yeah? Okay. So quiz on 5.1 and 5.2, sections 5.1, 5.2 on Thursday.